Today's lesson 3-12. We're going to be making predictions on what our products and our quotients will be and solving some multiplication and division problems with fractions. We'll be on page 99 of your workbook. On page 99 of your workbook, I'll be modeling questions 13 and 14. I'd like you, though, to try to stay ahead of me and work these problems with me. Number 13. Lucy spends 4 hours a week babysitting. Her sister, Lily, spends 7/8 as much time babysitting. Does Lily babysit for more or less than 4 hours? Usually I substitute their names with mine, and in this case I'm going to need to use their names to answer the question, so I left them there. But I can still insert myself into the question. If I'm babysitting for 4 hours and my sibling, my brother or sister, is babysitting 7/8 as much time as I am, who's babysitting more? I'll phrase it in a different way. My sister is babysitting 7/8 of the amount of time that I'm babysitting. We'll have to solve this problem eventually, so I'm going to write out what I just said. My sister babysits 7/8 of the amount of time that I babysit, which is 4 hours a week. Here I have a multiplication problem. The word of means that I'm multiplying, so I could change this to multiplication. And here I have an expression that I can make a prediction on. Again, we know that I do 4 hours a week. My sister only does 7/8 of what I do. If she did 8/8, she would do basically the same amount. But 7/8 means she's not even doing the entire amount. So she's doing less than I am doing. When you multiply a fraction times a whole number, we know that our answer will be less than our whole number. So my first answer is going to be that my sister babysits less time than I do. Part 2 of this question says we need to find the exact amount. So what am I going to need to do to my whole number 4? That's right, I'm going to need to turn it into a fraction. And before I multiply, and remember we're just multiplying straight across when we do, but before I do that I want to try to simplify by cross-canceling. So I'm going to use my cross-canceling technique. I'm going to look crisscross at my 4 and 8, and I'm going to divide both of these by 4. 4 goes into 4 once and into 8 twice. I'm going to look at my 7 and 1, and as soon as I see a 1, I know there's nothing I can do. I can also look at my 7 and my 2 and see if there's anything I can do there. And I can look at my 1 and my 1, which there's nothing there to do either. So now I can multiply straight across. 7 times 1 equals 7, and 2 times 1 equals 2. And I have an improper fraction, and I need to fix it. So 2 goes into 7 3 times, or 7 divided by 2 is 3. And there will be 1 left over, and the denominator will not change. And we will find out that my sister is babysitting 3.5 hours, which is only 7/8 of 4. So our prediction was correct as well. She's babysitting less time. Question 14. I have a rope that's 30 feet long. I hope that immediately you're thinking about drawing that rope and labeling it 30 feet. I'm going to turn that rope into a number line. I have to cut my rope into pieces that are 1/4 of a foot long. I don't know what that's going to look like, but I know I'm going to be cutting them into pieces, this rope. And I know that each piece that I cut is going to be 1/4 of a foot. Each of these equal places will be 1/4 foot. And the question is 2 parts again. The first part is prediction. Will I get more or fewer than 30 pieces? Now here I have a number line, and I've been told to cut my number line into a bunch of pieces, probably way more than I have here. But the point of this is that it's asking me to cut it up. And anytime I'm cutting something up, I'm basically dividing it up. And if I'm dividing this piece of rope, this 30-foot piece of rope, if I'm going to divide it up, then I need to divide. This is a division problem. I'm going to take my 30 pieces of rope and divide it into pieces that are only a quarter of a foot. How many quarter foot pieces do you think I will get? You don't even have to predict the answer. You just have to tell me, will I end up with more pieces than 30? Now, if we think about this for a second, if I have a 30-foot piece of rope, if I were to break this 30-foot piece of rope into 1 foot for each piece, then how many lines would I need to draw? I would need to cut it up into 1 foot. So my first line would be 1 foot. The second one would be 2 feet, 3, 4, 5, so on and so on until I get to 30. If I broke it into 1 foot pieces, it would take how many 1 foot pieces to get 30 feet? If you said 30, you're correct. Now, I'm not breaking them into large pieces of rope that are a foot long. I'm breaking them down into even smaller pieces of rope that are only a quarter of a foot long, 1/4 of a foot. It takes 4 of these fours just to make 1 foot. So that means that for every foot that I have 4 quarters of a foot. So if I broke my piece of rope into 30 1-foot pieces, and this is what that foot looked like, I would then have to break that into 4 equal pieces just to make 1/4 of a foot. So this would be 1/4 of 1 foot, 2/4 of a foot, 3/4 of a foot, and 4/4 of a foot. So you can see that if I broke them into 1 foot each, it would be equal to 30 feet. I would have 30 pieces of rope that were each 1 foot long, which would be equal to 30 feet. But I'm not doing that. I'm breaking them into even smaller pieces. So you can probably predict that I'm going to have more pieces than just 30. Because to have 30 pieces means I've broken them into 1 foot long pieces, but to break them into even smaller pieces means I'm going to have a lot more than 30 pieces. The prediction side of this tells me that I'm going to have more than 30 pieces. We've already created the expression, and now we just need to solve it. 30 divided by 1/4, we're going to take that 30 and turn it into a fraction. We're going to rewrite this problem. We're going to keep 30 over 1 the same because we haven't changed anything yet, so we're going to keep that factor the same. We're going to change our sign to multiplication, and we're going to flip or invert our second factor. We're going to try to cost cancel, but that's not going to be possible here because we have 1s on both bottom denominators. We're going to multiply then straight across 30 times 4, which is 120, and 1 times 1, which is 1. And now we can see our answer. It was an easy one to change. This is an improper fraction, and that equals 120. We're going to have 120 pieces if we break our 30-foot rope into quarter-foot long pieces of rope. You will go ahead and complete the next 2 problems on page 99 just as soon as we're done with going over page 100. First thing I'd like you to do is number 17. The puzzle penguin has been up to it again. He's made a mistake. Your job is to find the mistake and then write a response explaining what he did wrong. Number 18 is a fun question. Looks like you've won a prize and you get some music for your prize. However, the amount of music you get depends upon whether or not you understand which of these equations will yield you the greatest amount of music. So you can change your prize, but you have to choose which of these 2 equations you would use to decide how much music you're going to get. And you want to choose hopefully the one that will get you the most music. So which of these expressions will yield the greater answer? Remember, you have to assign a value to n and then solve it, and then you will know. But you have to use the same number for n. If n here is 2, then n here has to be 2 as well. For numbers 19 and 20, You're going to assign the value that they gave you for n, and you're going to apply it to your equation. Hopefully you chose the equation that will get you the most music. Assign the value 6 to that equation. So if your equation was n divided by 1/3, you would have 6 divided by 1/3. And then tell me what the answer is. How much music have you won? And do the same thing for number 20. If n was 12, how much music would you have won? You're going to use the expression, the equation that you chose. Number 20, you're going to discuss what you've learned about the size of the answers when you multiply and divide by whole numbers. Here we're dividing by the same fraction as we're multiplying by. So if you're using the same number as n, explain what you noticed about the answers. What's the patterns you see? Which one yielded the greater answer? Which one was smaller? Can you describe in words why one was larger than the other? Pause the video now and complete the rest of your workbook.